Hi students, welcome to Solving Logarithmic Equations, Day 2. We have a couple strategies for solving. The first thing we always want to do is condense one side or both sides of the equation. The second step, if there is log on one side of the equation only, then take it out of log form and write it in exponential form and solve it from the exponential form. Step 3, or the third scenario, if log is on both sides of the equation, then use the one-to-one property to solve. So here's an example. We have log base 2 of x plus log base 2 of 3 equals 3. We're going to condense. We only have log on one side, so let's condense log base 2 of x times 3. Or we would say 3x. Let's just write 3x instead of rewriting that all over again, where adding translates into multiplying. So think of adding and multiplying. Now we're going to take it out of log form, write it in exponential form. Notice log is on one side only. Take it out of log form and solve it from the exponential form. So we have 2 to the third power is equal to 3x. Starting at the base, 2 to the third equals 3x. 8 equals 3x. Divide both sides by 3, and we get 8/3. When we plug 8/3 back in for x, remember that after the word log, the base and the number after the word log can always be positive, never be negative. So 8/3 should be a good answer, and it is. Here's another one. We're going to condense into one logarithm. So that would be log base 2 of x times x minus 3 is equal to 2. Take it out of log form. 2 squared is equal to x times x minus 3. 4 equals, distribute, we get x squared minus 3x. We'll have to subtract 4, and I'm doing this because I'm going to have to factor because I have an x squared. When we factor, we get x and x, and a negative 4 times a positive 1 gives me a negative 4, but adds into a negative 3, and we get x equals 4 and x equals negative 1. We always check back to the original problem. If I were to plug negative 1 in for x, I would have negative numbers after the word log. So negative 1 is a scratch. That is an extraneous solution. However, positive 4 should work. It should be fine. All right, let's move on. Same thing. Let's condense on the left side. We have log base 7. 3 times x is 3x. Remember, adding and multiplying equals log base 7 of 32. In this problem, if we look back at our steps, if log is on both sides of the equation, use the one-to-one property to solve. 1-to-1, that means that 3x is equal to 32 simply because they're in the same spot, so they have to be equal. So the log base 7 of 3x is equal to the log base 7 of 32. So 3x has to equal 32. Divide by 3. 32 divided by 3 is a positive number. When I plug it back in for x right here, that would be fine, as long as you don't come out negative. All right, the next problem. Again, we're going to condense these two into one logarithm instead of two. So we have log base 2 of x minus 1 times x plus 2 equals log base 2 of 8 minus 2x. Because of the one-to-one property, x minus 1 times x plus 2 has to be equal to 8 minus 2x. So I'm going to write that down. X minus 1 times x plus 2 has to equal 8 minus 2x. We'll solve that. Continue. I think I'm going to need more room. So we'll have to FOIL x squared plus 2x minus 1x minus 2 equals 8 minus 2x. So x squared plus x minus 2 equals 8 minus 2x. I know I'm going to have to factor, so I'll shift everything from the right side over to the left side. So let's add 2x and let's subtract 8 from both sides. That leaves me x squared plus 3x minus 10 equals 0. I'm looking for two numbers that multiply together to give me x squared, so x and x. I'm looking for two numbers that multiply together to give me negative 10, so positive 5 times a negative 2. And outside inside would give me this middle term, positive 3x. X equals negative 5 and x equals positive 2. Let me go back to my original problem. If I were to plug negative 5 in, I would have log base 2 of negative 6. Unacceptable. That's an extraneous solution. If I plug 2 in for x, 2 minus 1 is positive. 2 plus 2 is positive. 8 minus 2 times 2 is positive. 2 should be fine. All right, let's check out another one. In this problem, we're going to condense the left side. Log base 3 of x plus 6 times x minus 6 is equal to 2. All right, I'll take it out of log form this time because I only have log on one side of the equal sign. So starting at the base, 3 squared is equal to x plus 6 times x minus 6. And if I square that, I get 9 equals, if I square this, I get x squared minus 6x plus 6x. They cancel out. And then last times last is minus 36. Let's add 36 to both sides. And we get 45 is equal to x squared, square root, x equals positive or negative square root of 45. If I bring up my calculator, the square root of 45 is 6.3. So we've got positive or negative 6.3 equals x. Okay, this is an exact answer. This is, of course, a decimal value. Let's see if we can plug in negative 6.3. Negative 6.3 plus 6 gives me a negative number. So negative 6.3 is not a working answer. Positive 6.3 will be fine. All right, before this gets too long, these are kind of all repeat of the same. Oh, let's do this next one. I want to show you what we would do first. We would add 1 to both sides. That's just 1, you know, add 1, add 1. So now we have log base 6 of x plus 1 is equal to 2. We have log on one side only. Take it out of log form, write it in exponent form. 6 squared equals x plus 1. 36 equals x plus 1 minus 1 from both sides. 35 equals x. Okay, if I plug 35 in, For x, I'll have a positive number after the word log, and that should be a working answer. That should be good. All right, I think we could maybe do one more, and I think we'll have covered everything. This one equals 0. To make this easier for ourselves, why don't we just add log of 2x minus 4 to both sides? Add log 2x minus 4. Then it will say log of 2x squared plus 7x is equal to log 2x minus 4. Now we can use the one-to-one property. Because they're in the same exact spot, we can say that they're equal to each other. So 2x squared plus 7x has to equal 2x minus 4. We'll need to factor, so shift everything to one side. So subtract 2x from the right, subtract 2x from the left. Add 4 to the right, add 4 to the left. The left side says 2x squared plus 5x plus 4 is equal to 0. Let's factor. And we have 2x times x. Two numbers that multiply together to give me a positive 4. Sadly, we would find that this does not factor. So our only option would be to use the quadratic formula. So that's okay. So remember the formula, x equals negative b plus minus the square root of b squared minus 4ac all over 2a. X equals negative b would be a negative 5 plus minus the square root of b squared. 5 squared is 25 minus 4 times a times c. A is 2, c is 4, all over 2 times a. Now we simply work it out. X equals negative 5 plus minus the square root of 25 minus 36 is negative. That gives us an imaginary solution. So this one has no solution. All right, there is a Delta Math titled Solving Log Equations Day 2. Have a great day.